Welcome to clickmyproject.com. Our product title is Implementation of Adaptive Fuzzy Controller on the Variable Speed Wind Turbines is comparison with conventional methods. Let us see about the abstract of our product. In this proposed design introduces a linear structure of wind turbine, operator and the pitch angle controller. Then a new method of adaptive fuzzy on the variable speed wind turbines was provided, and it was compared with PID and fuzzy logic controller, and the simulation results were analyzed. So when the simulations of each results using PID and fuzzy controllers and adaptive fuzzy PID controllers are provided, the observed advantages and disadvantages of the rotor speed and wind turbine of power can be introduced. It can be seen that in PID method the high overshoot is seen that in PID. Then that is the disadvantages, while it is overcome by using of fuzzy controller, and overshoot will decrease. The time of reaching of a sustained speed increases slightly, and to adaptive fuzzy PID controller, the less overshoot has provided a good and effective performance of system response. The use of adaptive fuzzy PID controller causes the system does not have any steady state error, and at all moments of time the response rate is better than PID and fuzzy controller. The importance of the amount of overshoot and rate fluctuation is that by reducing these parameters, in addition to reducing the cost of the fluctuations, maintenance, preventive care, depreciation in electricity generated by induction generator are greatly reduced. Next we see about the flow diagram. This is our flow diagram. The wind turbine is controlled by using of PID fuzzy and adaptive fuzzy controller. So generally first we apply only PID controller, then the overshoot is increases, and next we apply the fuzzy controller, the overshoot will be decreased, but the slightly changes in the speed of the wind turbine. And next we using the adaptive fuzzy PID controller, then the overall overshoot will be reduced and all the overall problem will be determined by using of adaptive fuzzy PID controller. So here we using four main blocks. One is the comparator, another one is the PID controller, another one fuzzy controller, and another one is the plant. Plant is consist of turbine and also wind generator and also the controller of the whole wind turbine. So these are the main blocks. In the main block, the output of the wind speed is compared with the main controller, then that is fed into the PID controller, then is compared with the fuzzy logic controller, then is fed into the plant. And also in fuzzy controller having two kind of membership function, one is input, another one output membership function. So compare with the input and output membership function, we derive the rules. So in that rules we find the which one is the output. For example, if flow the output is very low, that is the constraint of the membership function in the fuzzy controller. Then in the fuzzy logic controller we get the surface view. So using of that, which one is the error value, what the error value is generator, so how much that value is in the fuzzy controller. So that wise we developed in the PID controller. So the plant of wind turbine will be controlled by totally using of those adaptive fuzzy and adaptive fuzzy PID controller. So using of adaptive fuzzy PID controller, overall process will be increased. Next we see about the running process of our product. In this proposed implementation is done in Matlab simulating environment. In this proposed implementation we only did the control algorithm of the adaptive fuzzy control of the wind turbines. So here the paper also giving the control diagram only, those only we derived in this corresponding implementation, and also corresponding output only here we give. And the first one is the Matlab main window open. After that we creating a new model file. After creating that new model file, here we using only commonly used blocks and sources. So from that commonly used block we arranging the elements as per the circuit control given diagram, then we arranging that elements, then we control the parameters, then corresponding scope will be connected to the measurement devices across. So first one is the fuzzy controller. Here we using fuzzy wind fuzzy for two kind of membership function, and one output membership function. The membership function namely error and change in error. The output membership function name is output. So this is the first membership function of error, this is the change in error, and also this is the output. So corresponding membership function we can found the rules, how to frame the rules. So here the rule is shown here. So these are the error and change in error and the corresponding output. Next one, we can see the output of the surface. So fuzzy surface window will be open in the corresponding window. So after that, in the main Matlab window, we can, this is the input signal and this is the corresponding proportional signal, and this is after PID, output of the PID, and this is the random signal is given into the comparative. After then this is the upper part of the output signal and this is the lower part of the output signal. So those signals are the controlling signal. So those control signal is used to control the wind turbine, and also the overshoot will be reduced compared with the other kind of controllers PID and fuzzy. So similar to that, the controlling blocks are derived as per the given flow diagram. Thank you for watching this video.